Hi, this is another podcast from Coburg Maths. In this podcast we're going to be looking at combinatorics in particular pathways, and this is all taken from Purple Math 30. You can find a whole heap of Purple Math 30 resources at this website. The first clip we're going to look at is all about Pascal's triangle. The first pathway problem we're going to look at involves finding the number of possible paths between A and B in the image shown. Using Pascal's triangle, there is one path to go down the bottom and one path to go down the top. That's the minimum number of paths to go to those positions. This can be seen if we go back to that clip on Pascal's triangle. The number ones are going down the side. To go to the position shown, there are two paths, one across the top and one down the side, and so on. 3 paths to those positions till we get down the bottom, and there are 20 possible paths to go from the top to the bottom. Another way we can calculate the number of paths is to look at the directions we travelled. So we travelled east 3 times and then down 3 times to go from A to B in that initial example shown. So using combinatorics, we have 6 options of travel: east, 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 down, down, down. So really we can group those 6 different ways in 2 lots of 3, and using the permutation rule we get above. Now this example is a little bit more complicated because it's in 3 dimensions, but if we went east and then down and then forward, we could go from A to B. Have a think about how many moves of each we need. So we have our 3 directions of movement: east, down and forward. And that's the number of movements we had in each direction. So we can group and use the permutation rule again, and we get that shown. Now this example is a little bit more complicated because it's not a regular pattern as shown in the other 2 examples. Have a pause and think about the possible number of paths. So we can start filling in our numbers according to Pascal's triangle as shown. We get 35 possible paths to that point down in the middle corner, and then we can consider the bottom half of the diagram, and we get 210 altogether, which is the first part multiplied by the second part, so 35 times 6, and that gives us 210, which is the total number of paths to go from A to B in this example. Have a go at this question, number of paths from A to B. So maybe you'd like to pause the clip. The next screen will show the solution. And here's the solution for that previous problem. Here's another example you might want to have a go at before looking at the next screen. So pause now. In this problem we're interested in finding a number of paths from A to B that must go through the dot shown. So this is a little bit more complicated. Again, you might want to pause the clip and have a go at this before looking at the next screen. So you can see we're varying Pascal's triangle slightly for each question, but it's essentially the same rule for each problem. We add the previous 2 corners together. Here's a slightly more complicated example. Can you see how we got 6? For the first half of the diagram, maybe draw up your own Pascal's triangle to represent the situation shown. Here's another problem. Can you find out how many times a ball would bounce if it was to go from the start to X? The remaining 17 problems you might want to attempt on your own. So you can pause the clip at any time to look at the particular question you're interested in, and you can go to the website that's at the end of this podcast and search for pathways for some of the work solutions. Remember, these are also available through Purple Maths 30. Thanks for listening.